Oh, you already know what time it is. So, before we start, I just want to say that this will be a shorter video. I got sick over the weekend, and I was too sick to even work on my script most of the time. I really spent almost the entire week completely knocked out. But, without further ado, let's talk about hydrothermal vents. I have always loved hydrothermal vents because whenever I was in Catholic school, I had this awful science book. All of the textbooks were like over 20 years old, and those were just the young ones. I got science books and the science book I had when I was in like 3rd grade was from whenever hydrothermal vents were a new and exciting science. And I was immediately like enamored with them, mostly because of the tube worms. Look at them. They look like socks. They're so cute. But I just think that they're really cool, and they're not really shown on a lot of documentaries and stuff because there's not really a lot of biodiversity down there because they're at the bottom of the sea and cold until you get really hot, and then chemosynthetic ecosystems are really interesting, but there's not really a lot there. So let's start for people who forgot what they learned in elementary school or high school or university, or just didn't take those kinds of classes. This is where hydrothermal vents are. Now, if you remember this from those classes, is there a little pattern you're noticing? Is there a little ring of fire thing going on? Yeah. These hydrothermal vents pop up along the lines of plate crossings, pretty much. And there are a couple in Hawaii and other hotspots, but mostly they're along the Mid-Atlantic Ridge, they're along the Ring of Fire. They're really cool. So, what happens is whenever these plates move apart, magma comes up and you get this magma, and in that magma is hydrogen sulfide, and this superheats the water in these zones. So now we can talk about chemosynthesis. This is what photosynthesis looks like. This is what chemosynthesis looks like. If you can't tell, they're pretty similar processes, except photosynthesis uses the sun, but there's no sun at the bottom of the ocean. And in this way, chemosynthetic bacteria substitute sunlight with hydrogen sulfide and other sulfur compounds and make sugar for themselves and off-put those other sulfur compounds. So really, there's, I think, like a few species of chemosynthetic bacteria, and they are the backbone of this entire ecosystem. They live on the floor, they live, floating around the water, and my favorite, they live in tube worms, and they give the tube worms some of their sugar in exchange for a place to live. But there are so many other cool things. Like, there's this thing called a Yeti Crab, which has cilia all over its arm, all over its front claws, which are, fun fact, as long as its body. That's so cool. But these cilia are specifically made to farm this bacteria, pretty much. But it's also used to hunt, which is incredibly cool. There are worms there are these really neat little sulfur worms that just crawl along the surface and eat them. there are a lot of other crustaceans that live on this area, and all of them are blind because there's no light down there, so there's no use for eyes. They put more effort into into more sensitive surface nerves. And I just think that this is one of those things that I've never been able to talk about at length because there's just not a lot to talk about, but it's an incredibly interesting topic. So, thank you. Getting in underwater, huh? Alright, bye.